let's see what is measurement. It is quantification of any physical quantity. When I say quantification, you're able to find how much it is. That how much of any particular physical quantity, you're able to get it from measurement. Now, what is a physical quantity? A physical quantity is a quantity pertaining to any physical object. Suppose I have this stylus now, this pen. This pen is a physical object. Or I have this panel now. This panel is a physical object. Anything that you are able to perceive physically is a physical object. And if you are able to quantify that in terms of quantities, if you are able to find how much it is in terms of quantities, then that is a physical quantity. So, any physical quantity you can find by measurement. So, how much it is? So, measurement is finding how much of any physical quantity is. So, all objects around us can be quantified by measurement. Suppose you have a road. So, if I say how big the road is or how small the road is, so how big means how much it is. Big means there should be some quantification to understand how big the road is or how small the road is. So here, what is that quantity you are able to find? Width of the road, right? So width is a physical quantity of this road. So then only I can say if this is the width of the road, 50 feet or whatever it is, this particular road is this much big or this particular road is this much small. So there should be some physical quantity to quantify how big or how small it is. Similarly, so width of the road is a physical quantity. So how you get it? You get it by measurement. Similarly, suppose if you want to find height of a child and I say child is short, my child is tall, how tall she is or how short she is, he or she. So short means there should be some quantity to specify, right? So the height here is a physical quantity now. Height. So you're able to measure it. So any physical quantity can be, it should be measurable. Any physical quantity has to be measurable. So height of a person, it is measurable quantity. So these are all some physical quantities here. Mass. So what are the physical quantities? Let's see. Mass, it is a physical quantity. So we see in detail what each of these physical quantities are. Just try to understand, because suppose I have an apple and if I say there are big apples in the market or small apples in the market, so how big they are, how small they are, that I have to quantify in terms of mass, right? Similarly, if I say it's a big car, big means there should be something to specify it. So length of the car. So if I say length of the car is so much, okay, then I can understand, okay, this is so much big, or length of the car is less. I can understand this is a small car. Similarly, suppose if someone is having fever, how can I specify that? There should be some metrics to measure it, right? Some quantification process is to be done. He's having fever. Fever means how much? More, less. There should be some quantity to specify. What is that quantity here? Temperature. Similarly, you're standing outside and you feel a lot of hotness there. If you say there is a lot of hotness outside, or suppose you are sitting inside a room, it is cool inside. If you say it is cool inside, how much cool or how much hot outside? These things ought to be quantified, right? They're all physical quantities. So temperature is a physical quantity. Similarly, in the case of an event, suppose If you ask someone to complete the task faster, or you have to finish your work in short time or in the given duration, months, how much duration it is, there should be some quantity to specify it, that is time. You are specifying by this time you should complete. In so much time means maybe in next 30 minutes you have to complete this task, or next 30 seconds you have to complete this task. So there should be some quantity to specify it. That quantity is time. Similarly, you say there is lot of light outside. So lot of light means what? How can there should be something to specify that light also. That quantity is luminous intensity. And you're able to see all these are the physical quantities. All these are measurable. Mass, I know, I can measure. Length, I can measure. Time, I can measure. Temperature is measurable. Luminous intensity is measurable. All these are physical quantities which are measurable. Now we see what are the units for this. Mass, kg. Length, which is measured in meters. Temperature, Kelvin. Time in seconds, and luminous intensity in candela. So these are some physical quantities which are measurable. When I say physical quantity, it is measurable. So these are all physical quantities. Now the point is, what is to be measured? That is a physical quantity. So height is to be measured. Height is a physical quantity. Length is to be measured. Length is a physical quantity. And how much? What is a physical quantity here? That is, length is a physical quantity. And how much is something that you get by measurement. And how much you are going to get it through measurement. And that measurement you have to specify in certain units. So let's see what are the physical quantities. These are all fundamental physical quantities. There are derived physical quantities also. First, let us try to understand what are the fundamental physical quantities, their units. So length is a physical quantity, and unit is meter, where symbol is m. Similarly, mass is a physical quantity. Kilogram is the unit. Kg is the symbol. Time is a physical quantity. Second is the unit. S is the symbol. Temperature is a physical quantity. Kelvin is the unit. K is the symbol. Current. So current, how much current if you say someone there is a lot of current flowing through, how much? There should be something to specify it, right? So ampere, that is also physical quantity. A is the unit. Amount of substance, mole, MOL is the symbol. Now, intensity of light, candela, CD is the symbol. All these 7 physical quantities are fundamental physical quantities. I'll tell you what are fundamental physical quantities. Fundamental means they are not derived from any other quantities. Directly you can measure these quantities. I can measure length directly, mass directly, time directly, temperature directly, current, amount of substance, intensity of light. All these stuff I can find or I can measure independently. So all these are fundamental physical quantities. Next, what are SI units? So whatever the units you have seen in the earlier slides, we have seen a lot of units there. All these units, these all are SI units. There are so many units: CGS units, MKS units, FPS unit system. Units means, suppose if I want to measure length of Suppose if I want to measure length of a car now. Length of a car I can measure in meters. It can also be measured in centimeters. It can also be measured in inches. So many units are there. So what is SI units? It is actually SI stands for System International in French. But actually SI means it is international standard. So standardization of units throughout the globe. So what happens is, suppose if you are having a particular unit system, suppose you are having a particular unit system in India, and you are having some other particular system of measurement in China, or you have some other measurement system in US, some other in UK. Then suppose if I specify the length of car is so much in particular system which we are following, and if America is following some other system, and if they have to convert that into their particular unit following system, right? For example, length of the car is some 3 meters. Now if someone is following in inches, now they have to convert into inches, and someone is following in centimeters, they have to convert into centimeters. In order to avoid this confusion, all the units followed globally, that is internationally, are standardized. These units are known as SI units. So this is actually followed throughout the globe. So in order to avoid the confusion, so there shouldn't be confusion from one country to another, from one place to another. So universally, if units are same throughout, then it is easy to specify any physical quantity, right? So that's why SI stands for International Standard Unit System. Okay, we have seen fundamental units earlier. When I say length is a fundamental unit now. For example, here, if I want to find the area of this rectangle, so can I measure the area of rectangle directly? No. I can measure length, I can measure width. From these two, I can find what is the area. Directly I cannot measure the area. So what are the fundamental units now? This length is a fundamental unit, this width is a fundamental unit, this length is a fundamental quantity, width is a fundamental quantity, and this is a derived quantity. So let's see what it is. So fundamental unit is independent. So I need not depend on anything to find the length. Directly I can measure the length using some measuring instrument. So similarly, if I want to find width of this rectangle, I can measure using a ruler or whatever the measuring instrument we have. So no need to depend on anything. But so M is a fundamental unit. So M means meters. So I'm talking about all units in SI system. So length is in meters. So length is fundamental quantity. Width is also a fundamental quantity which is also measured in meters. So length, yes, it is measured independently. Width, it is also measured independently. Now, area. How to find area? Area I can only find after getting length and width. So, length is measured in meters. So, meter is a fundamental unit. Width I measure in meters. Width is also fundamental unit. Now, area. What are the units of area? So, length into width for rectangle, that is meter square. So, meter square or area, unit of area is a derived unit. You are deriving it from these two. So that's what derived units are. Derived units means you are deriving them from fundamental units. So meter square is a derived unit. You are not getting meter square directly. I cannot find the area directly. I have to find length. I have to find width. So after finding length and width, I get what is the area. So length and width are fundamental quantities. Area is a derived quantity. So length, which is measured in meters. So meters is a fundamental unit. Meter square is a derived unit. So if you are deriving unit from other fundamental units, then that is a derived unit. So let's see some more derived units here. Suppose someone is moving in a car and we say he is moving faster. Faster means how much? There should be some quantity to measure it. The quantity to measure it, what is the quantity we use to measure how speed he is going? There's a velocity, right? So velocity is to be found out now. How you get it? I cannot measure the velocity directly. So I need to find what is the distance traveled and what is the time taken. So then only I get what is the velocity. So now distance traveled or displacement is a fundamental quantity. Time is a fundamental quantity. From these two, you are deriving the velocity. So velocity is meters per second. What are the units for this? So meters per second, because displacement or distance is in meters, time in seconds. So velocity is a derived quantity which you are deriving from length, that is the distance traveled, and time. So that's why it's a derived unit. Similarly, acceleration is also a derived unit. Suppose force is there. Force is also a derived unit. So what is force? Mass into acceleration. So mass is a fundamental quantity. Acceleration is derived quantity. So now you are getting force from this. So force is also a derived quantity. So Newton is a derived unit. N means Newton. So what is the least count? So you are having a measuring instrument. For example, the basic measuring instrument what we have seen is a scale, a ruler. So this is a basic measuring instrument which we have seen, all of us seen. Now if you see a basic scale, there are readings in centimeters and mm. Now in this scale, let this border, whatever the numbers you are able to see, 1, 2, 3, 4, all these are centimeters now. And these small readings are mm. We know 10 mm is equal to 1 centimeter. Now, we know 10 mm is equal to 1 centimeter. So therefore, each small division is 1 mm. So what is the least, or I would say smallest measurement that you can make using this scale? The smallest measurement that you can make using this scale is 1 mm. The smallest measurement that you can make is 1 mm. So suppose if you want to measure some 3.5, I cannot measure 3.5 mm because I have readings only for 1 mm, 2 mm, 3 mm. After that I have 4 mm. But I cannot find what is 3.5. Suppose if you want to measure something having a diameter of 3.5 mm or size of 3.5 mm, I cannot measure here because these divisions, smallest division I am able to find on the scale is 1 mm. So less than that I cannot measure accurately. So this is having a least count of how much? 1 mm. So what is least count? The smallest reading or the smallest measurement that you can make is the least count of particular device. For a scale it is 1 mm for this particular scale. So 1 mm is the least count. Similarly, you are having a pressure gauge here. So you can see, so it starts from 0 and the maximum pressure that you can measure is 10 bar. So in between, from 0 to 2, there are 10 readings. I will say 0 to 1, this is 1. How many readings are there? 5. So each division is how much now? 0.2. 0.2 bar, 0.4 bar, 0.6 bar, 0.8 bar, 1 bar, 1.2, like that you are getting. So each small division is how much? Each small division here is how much? Each small division here is this small division. Whatever the small division you are having, this is equal to how much? This is equal to 0.2 bar. So therefore, the least count of this is how much? So the least count of this is what is the least count now? 0.2 bar. So 0.2 bar is the least count of this particular pressure gauge, because that is the smallest pressure I can measure. Suppose if I want to measure, I can measure 2.2 bar, but I cannot measure 2.3 because of course there is something in between I can judge, but accurately I cannot measure. I can measure 2.2, 2.4, 2.6 because readings are there. Similarly, you have vernier calipers. All of you might have seen vernier calipers in your school laboratories. So, if you look at this, what is the concept behind vernier caliper is, you see this is the main scale. On main scale, let us see, one main scale division is 1 mm here. So, this small division here, so this small division here, so this division on main scale, so this is 1 mm. So this from here to here it is how much? 1 centimeter. Now if you look at this, how many? There are 10 divisions, right? So 10 mm. So now this 10 mm is divided into, see, 10 divisions are there, 10 mm. So out of this you are able to see here only 9 divisions, right? These 9 divisions. So this is the 9th division. So these 9 divisions, they are divided into 10 divisions here. So these 9 main scale divisions, they are equally divided into here 10 vernier scale divisions. So 10 vernier scale divisions. So that you can see here. So this 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9 scale are divided into 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 divisions. This is your vernier scale. So what is this? This is your vernier scale. This is your main scale. So 10 divisions on main scale are divided in, 9 divisions on main scale are divided into 10 equal divisions on vernier scale. Now the key here is, so if this is 1 mm from here to here, okay, from here to here, how much this is? 1 mm. How much this will be? So this is 1 mm. So total is 9. From here to here it is 9, right? From to here it is 9. So 9 is divided into 10. So what is each now? Each, this is 0.9 mm. So this division on main scale is 1 mm and this division on vernier scale is 0.9 mm. This is 1 mm, this is 0.9 mm. Now, what's the difference? Here, see, you can now see here. So, what is the difference here? Here, the difference, this is 0.9 mm, this is 1 mm. So, difference for first division, whatever the difference it is making, this is how much? This difference is 0.1 mm. The difference between that is first division of vernier scale and first division of main scale here. How much difference it is having? 0.1 mm. Similarly here 0.2. This difference is 0.1 mm. This difference, whatever the difference you are able to see, this is 0.2 mm. Similarly here 0.3, here 0.4, here 0.5, here 0.6, next 0.7, 0.8, 0.9, and here it is 1 mm, because this is 9 mm and this is from here to here. This is, so total this is 9 mm but divided into 10 divisions, right? Therefore here it is total 10 mm. So last division you are getting, after this you are getting scale. So now for first division it is 0.1 mm difference, for second division it is 0.2 mm. Similarly if you take for sixth division or fifth division, you take sixth division, this difference is 0.6. That means suppose if I move this vernier scale, I move the vernier scale, right, this, right, to measure. If I move the vernier scale such that the first division coincides with the first division here, then what is an individual? So first division, if it is coinciding, how much it is moving? 0.1 mm. Suppose second division is coinciding with the main scale division, how much the scale is advancing vernier scale? 0.2 mm. Similarly, this sixth one is coinciding with the main scale division. So if it advances like this, if total scale advances, so how much it is advancing towards this 0.6 mm. So that's why while measuring, what we are doing, we see next, this is 0.6 mm, right? So one main scale division is equal to 1 mm, one vernier scale is equal to 0.9 mm, least count is equal to 1 MSD minus 1 VSD. This is the logic here. So actually in the scale earlier what we have seen, the least that can be measured is only 1 mm. Here you can measure 0.1 mm because 1 MSD minus 1 VSD. So what is 1 MSD? 1 main scale division. 1 main scale division is 1 mm. And what is VSD? 1 vernier scale division. 1 vernier scale division is 0.9 mm. So what is the difference? The smallest difference you are able to find? 0.1 mm. So you can measure anything that is equal to that means you can measure accurately to a low level of 0.1 mm. Suppose if it is 0.05, that we cannot measure using this vernier calipers. The least that can I measure accurately is 0.1 mm. Therefore, so how it is 0.1 mm? We see. So least count is 0.1 mm. So the least count is 0.1 mm because 1 mm is the main scale division, vernier scale division is 0.9 mm, difference is 0.1 mm. Now we see practically how it is. Suppose if you want to find the diameter of this, this is your main scale division. So on main scale division I can measure 1 mm, 2 mm, 3 mm, 4 mm, whatever. Suppose I am measuring this. This is my vernier scale. Suppose I am moving this vernier scale to the right and you see which division is coinciding with the main scale division. As I told you earlier, this vernier scale, if sixth division is coinciding with the main scale, that means how much it advanced? It advanced 0.6 mm because if this coincides with this, it is exactly 2. After that it is advancing. How much it has advanced now towards this? So if first division coincides, it is 0.1 mm. Second division coincides, it is 0.2 mm. So it advanced. Which division you are able to see? This is advanced. So 1, 2, 3, 4, 5, 6th division is coinciding. That means when 6th division is coinciding, how much it has been moved from this position? So this blue line has to be here, right? So how much this has been advanced here? So this is advanced through this much. So how much it is? 6th division is coinciding. So how much it has advanced now? If 6th division is coinciding, so it has moved through 0.6 mm. That's how you find actually the measurement. So how we get that 0.6 with least count into the division. whatever the division on vernier scale is coinciding. That is actually the logic. The logic is, if this is exactly with some main scale division, the first division is making a difference of 0.1 mm, second division is making a difference of 0.2 mm. So similarly, if it is advancing towards right, and whichever the division is coinciding with the main scale division, that actually advances. Suppose third one is advancing, that actually advances 3 into 0.1. So 0.3 mm it is advancing. Suppose fourth division is advancing, it is advancing 0.4 mm. Fifth division is advancing, it is advancing through 0.5 mm. That's how it is. It's very simple. Now, each is making 0.1 mm. So first division, second division, third division, fourth division. Suppose ninth division is coinciding, it is 0.9 mm. That's it. Okay. So sixth division. So MSR is, that is main scale reading is 2. So 1, 2 and 2 point something. But this something is how much you have to find. This something you are able to find with which division is coinciding. So sixth division is coinciding. So diameter is main scale reading plus vernier scale reading into least count. So 2 sixth is coinciding, therefore 0.1 is the least count, 2.6 mm is the diameter of this. Suppose we have similarly screw gauge. Screw gauge is also a measuring instrument which is available in school laboratories or in college laboratories. So the concept is different. In the earlier scale we have seen, in the vernier scale, the least that can be measured is 0.1 mm in that particular vernier calipers, where one main scale division and one vernier scale division, the difference what you are getting is 0.1 mm, because one main scale division is 1 mm, one vernier scale division is 0.9 mm, the difference is 0.1 mm. But if you want to maintain the difference of less than that, or if you want to measure accurately to lower level further, that means, for example, in the earlier case we have seen 2.6 mm we have measured the ball diameter. Suppose if you want to measure some 2 point next division, for example 3.45 mm, so then what should be the least count of this? 0.01 mm. Suppose if I want to measure 3.34, 3.45, 3.56, 2 decimals after point, that is actually it is the least count should be 0.01 mm. If you want to get the least count of 0.01 mm vernier calipers, it is not easy. The number of divisions you have to make it is not actually feasible. But in vernier scale, the concept is, this scale is known as circular scale, and this is your main scale. So when we rotate this circular scale advances like this, rotating clockwise and anti-clockwise based on the direction, it advances or come back. Now, so let us see how this works actually. The screw gauge actually depends upon the screw on which it is rotated. The pitch of the screw is something that will determine the least count of this. Let's see how it works. Now, so this is the scale. This is a circular scale. So 0 is coinciding with the center scale now, center line. Now 1 mm, for example, here to here, this on the main scale, one division, this division is 1 mm. So half mm, 1 mm, 1.5, 2, whatever it is. So the smallest division here is 0.5. So you can see here. So its total is 1 mm. So again I have readings here in between, therefore 0.5, 0.5, 1, 1.5, 2, 2.5 like this. Now there will be a screw inside the sleeve. This is a circular scale with a sleeve like this. Now inside it is a screw. When I rotate this on the screw, based on the threads here, it will advance either forward direction or backward direction. So how, let's see, like this. So there is a screw now, thread is there. Now when I rotate this, it actually advances the sleeve. The sleeve actually advances based on the pitch of this. So what is the pitch of this thread? That is one thread to other thread. That is actually the pitch, this one. So from here to here, this is actually known as pitch. That means for this one complete rotation, if I rotate this sleeve completely, that is through 360 degrees, this actually advances, this whatever the circular scale is there, this actually advances equal to the pitch. So it advances one thread or it comes back one thread. So one complete thread it will move. So that's why for one complete rotation, so this is advancing actually, which is equal to the pitch of the screw. Now that is actually the logic here. Now what is important here is how many divisions are there on the circular scale. In this particular, there are 50. You can see 5, 0 to 5. On the other side, it's rotating like this. Again, it is coming back 45, 50 divisions finally. So 0 to 50. So what it means is, if I completely rotate through one rotation, that is 360 degrees, from 0 to again 0, it advances through pitch of the screw. So let us see, pitch of the screw here is from here to here. That means 0.5 mm. The pitch of the screw is 0.5. Let us assume that it is 0.5. Therefore, this advances after one complete rotation, it advances 0.5 mm. So that is equal to the pitch of the screw. So how many divisions you are actually rotating here on circular scale now? 50 divisions. So for 50 divisions, it is advancing 0.5 mm. Suppose, that means if I rotate through one division, so it's 0, right? If this coincides here, so if I rotate this, so if I rotate in the clockwise direction like this, and this advances and this goes to red line, this one, this takes red line. So for 50 divisions, it is actually advancing here 0.5 mm. So for one division, how much it will advance? So for 50 divisions, 0.5. So for one division, it is 0.5 by 50. That is 0.01 mm. That is the least count. So let we see in detail what it is. So least count is what? Pitch of the screw. So how much it is advancing, pitch here, the pitch of the screw, based on it will advance by number of divisions on circular scale, by number of, as I told you. So least count is pitch of the screw by number of divisions on circular scale. What is pitch of the screw? How to find pitch of the screw? Distance advanced by circular scale for one complete rotation, as I told you in the earlier here. So if I make one complete rotation of this thimble, how much it advances here on this main scale? That is actually pitch of the screw. If it advances 1 mm, then pitch of the screw is 1 mm. If it advances half mm, that is 0.5 mm, then pitch of the screw is 0.5 mm. Okay, so pitch of the screw in our case, let us take it is 0.5 mm. The number of divisions on circular scale are 50, which we have seen. Now, least count is equal to 0.5 by 50, 0.01 mm is the least count. This is the basics of measurement and basic measuring instrument we use in your schools and colleges. So this is actually the syllabus based on your IIT, JEE, NEET and other competitive exams. So whatever the physics is involved, wherever the physics is there in your competitive exams, whether it is IIT, JEE or NEET or any other state entrance examination or any other entrance examination for that matter, I'll try to cover all the physics fundamentals in the coming videos. Just go through them.